Good morning, this is Mr. Henry Clement. Okay, today we are going to do some divisions. After weeks, okay, we have learning in the whole chemistry. So we are going to do it again. Okay, so I think just a revision, a review. This is an atom. Okay, atom is a nucleus, or you can say this is nucleon, and surrounding by the electron cloud. Okay? In the nucleon or nucleus of the atom, we have the neutron and the proton. Okay. And we learned about this is a positive charge, this is a negative charge, and neutron has no charge. So and then we learn about the history. Initially, with Thomson thing, it looks like this, and then also later, Ernest Rutherford, okay, fired up some particle source through a very thin gold foil, and he found out actually most of the particles actually pass through the foil. You know, that means it proved that this foil, even it looks so solid, but there's a lot of empty space in the solid. Only very rare particle bounce back. Okay, so that James Chadwick later they proved that there's a neutron which is in the middle of the nucleon. Okay, then we learn about the periodic tables. Okay. Okay, and following the history, okay, and the development. So now we have that symbol above the name, and we have two number. The smaller numbers, the position may be changed, but the smaller numbers is the proton number, and the big number is the nuclear number, which is the mass. Why? Because the proton and the neutron are carrying out a relative mass of 1 unit, but electron is like slightly smaller, maybe about 1/2000. I think it's quite close to 1/1836. Okay, so the electron is you can neglect the mass of the electron, but this is the proton and the neutron. Okay. So for example, if this is 20 and for example, I take this one, 3 and 7 for lithium. So we know that this is the atomic number or proton number, which is tell you how many proton, and the 7 is the mass, which is the total of the proton, which is this 7, and 7 minus 3. I think there's another 4, right? So there are 4 neutron there. Okay, so you can always deduct the mass number, atomic mass number or nuclear number with the proton number, then you can get the number of the neutron. Okay, and then we're learning about group 1. Okay, group 1. Group 1, we call it the alkali metals. Okay, group 1 has extra. Okay, you can see the 1 at the outer shell. So we should write it as 21, 281, 2881 for this one. 2, 288 or 281, 2881. Okay. So for this, you can see the proton number is 3, the neutron has 4, so the mass is 7. You add up and you can get the mass number. Okay. So this is 11 proton and the mass is 11 plus 12, you'll get a 23. Okay. So then we also learn about other groups. For example, group 7. Group 7 is different. The outer layer have the 1, 2, 3, 4, 5, 6, 7. You see? Outer layer have the 1, 2, 3, 4, 5, 6, 7. So to get an 8, actually you need another 1. So for the group 1, it tends to lose 1 electron so that you can get a stable outer layer, which is 2, 8, 8. Okay. So this one to get a 2, 8, so 2, 7, you need to gain another 1 electron so that to become a very stable status. Okay. And then we go to the group 8, which is so-called a normal gas. Okay, the outer layer is already stable, is full, so we call it inert or unreactive. Okay. Okay, this is the books. If you have the same books, you can always try to do this. Okay, take a picture and do this. Okay, and then later show me. Okay, I can try to mark for you. No worry. Okay. Burning is also combustion. Something plus oxygen then become the oxide. Here the carbon oxygen become carbon dioxide. And then we have other oxidation states. And then we learn about exothermic. Exothermic is given out heat. Okay. For example, this potassium plus water, the metal plus water will become the hydroxide and hydrogen. And the reaction here is given out heat. For some other metal, which is not in the group 1, group 1 is so reactive. You cannot use the group 1 for acid, only for water, already can cause some explosion. But in group 2, such as magnesium and other metals, but this is not for calcium. Calcium is too reactive as well, even though it's in group 2. Okay, so you still can observe some temperature rises. Okay, endothermic process. Okay, taking in the energy from outside, so the outside will feel some cooling effect. Okay, as compared to exothermic, you can feel the experiment. As a result, you can feel the hot and the warm. Okay, so these are some example we have gone through with you, so I don't want to repeat. Okay, so enzo or endo, this one we have done also. Okay. Okay. This is an exothermic. Okay, this is an expensive idea because it's difficult to making of compartment in the tin so that the food and drink are not contaminated. Okay, so this is a soup. If this is covered outside, you pass the water, okay, and then the heat will actually cook the self-heating meal. Okay, I think nowadays it's quite famous already. Yeah. Okay, and then you have the chapter 6. Okay, we learn about reaction with the metal with oxygen, to become oxide. Okay, and then reaction with water to become hydroxide. Then with acid to get a salt and hydrogen. We also learn about reactivity series. Okay, then this is the chart. And the stronger one, the most reactive one, you will displace the least less reactive one. We call it a displacement reaction. Okay, and then some use of displacement especially in the extraction of the iron, and to repair the rail, which is the thermite reaction. And we have number 7, which is the salt. Salt is a metal with the group 7, okay, and can always make the colorful things. Calcium carbonate, magnesium carbonate. Okay. Preparing salt using metal and acid. Yeah, this is important. Okay. Because we know that zinc acid and metal will get you salt and hydrogen. Okay, we have learned a few techniques there. I think next one will be the metal carbonate. Let's start the metal with acid, metal with water. Now we have another type which is metal carbonate with acid. Okay, the carbonate acid with carbonate with acid will give you salt, water, and one more thing, which is the carbon dioxide. Titration is important as well. Okay, maybe you can take a picture and then try to do it and send it to me via my channel, Handy Clement, or Dear Friend Colorful Note. So mentioning the rate of the reaction, this is something like doing graph and record the thing. Okay, so rate is something you did with the time. So you have the time here. Okay, in a certain interval of time, you record the total volume of the gas produced, and then you can make a graph. So initially, you will be like steeper because the reaction will be faster, and later will be flat because all the reactant has finished reaction. Okay, changing a rate. Okay, so changing the rates like it's like that. We have something. Okay, because to get a successful reaction, the molecule or the compound need to be react together, which is called the collide together collision. Okay, and the surface area is the key. Okay, the larger the surface area, which is the small and fine. Okay, have the more surface area. The next one will be the temperature. The higher the temperature, the faster the reaction. Why? Because the particle inside higher temperature will tend to have the more energy and move faster. So the collision will be more successful. The next one is about concentration, which means that the more concentrate liquid is, that means that there are more particles per unit volume, so that the successful rate will be higher. 3+1 just now, surface area, temperature, and the concentration will affect the collision, and then we have another one, but this is not about the collision. This is about just to speed out, just to speed out the reaction. Okay, so catalyze will be used here. Okay, in biology we call it enzyme, but normally we have the name call it catalyze. So there is some hydrogen peroxide attached. Okay. Okay, that's all for today's. Okay, so I hope you enjoy this. Okay, and later to see you again in the next chapter. Bye.